Hello, good evening, everyone.
Good evening, ma'am.
Good evening. How are you all?
Good, ma'am.
Have you gone through the three demo sessions I have shared in the group? Have you all gone through the basic sessions? Just overview of UVM.
Yes.
So, can you tell me what is the difference between sequence, sequencer, and driver sequence item? What is the difference between sequence, sequence item, sequencer?
Sequence item is a basic data item which includes the basic stimulus, whatever we require in a stimulus. Sequence is take the sequence item and we can drive those into to generate a particular stream of stimulus. Driver is basically take the sequence
Okay, just wait.
item and
What about remaining? Sheetal, Pranay, Chakravarti, remaining Ravikant, Samshriti, Sandeep, Uma, Silpa. Can you tell
Okay.
me what is the difference between sequence, sequencer, and sequence item?
Here, sequence item and sequence is object, and sequence item contains the transaction which we are going to perform, and sequence will do the transaction. It will do randomization, and we include constraints in the inside that. And um, in sequencer is just intermediate. It transfers the transaction. It transfers the data between the sequence and driver. It act as intermediate between sequence and driver,
Okay,
and sequencer is component.
okay. What is the difference between TLM port and analysis port? Others? Anyone? What is the difference between TLM port and analysis port?
TLM port is used for communication between components, UVM components. It is like one port and one export. Analysis port, it is communication between multiple components.
Okay. Yeah. Okay. So have you gone through what is the port, export, implementation port, and how the communication between
Yeah.
Pranay, Shilpa? Okay. What are the different phases are there in UVM? What are the different phases in UVM? What is the use of phases?
Build phase, connect phase, end of elaboration, run phase, export, check, final report. Yeah, like that.
Okay. What is
So
the
where
use
the
of configuration data types in database in UVM? Configuration database.
to share the information between multiple components of UVM test bench and to configure the test bench like which agent will be active, which agent, the to basically configure the test bench as well.
Okay. Okay. So what is mean by RAL model? Register abstraction layer. So what is the use of RAL model?
It is used for register verification. Like It is used to verify the memory in our DUT design.
Okay. Gurushant, can you answer what is mean by RAL model? What is the use of that?
Register mode will be different to store how the data is stored in register mode. For that, we will use RAL mode.
Okay. In RAL model, what is the difference between predictor and adapter?
Mm.
In RAL model, what is the difference between predictor and adapter? Have you attended first session, Gurushant?
Yes, ma'am.
Have you not remembered? How the register sequences are transmitting to DUT in RAL model?
I have to study this RAL model again.
Last session also you said same thing. In the last session, we discussed clearly about RAL model. What is the use of RAL model? What is meant by adapter, predictor, how the memory mapping. Okay. So today is the first session, right? So I think you already know the basics. So I think no need to cover with the basics. Okay. So we will start with the agent. Okay. So today we will look into UVM agent, how to write the program for UVM agent. Okay. And what are the different types of UVM agent and the flow of sequence, sequencer, and a driver. Okay, so what methods we need to consider and how the flow of execution, everything we will discuss today. And next in the coming sessions, we can start with the TLM port and one-day phases, one-day factory registration, like that. Theory wise, everyone got the clarity, what is what. Okay, but we need to go in depth of programming mostly. Okay, today I will share you the tool, everyone. QuestaSim we can install directly. The cracked version. So I will share you the some recorded session video for how to install the tool. If you already have the tool, you can use the same. Or if you don't have the tool, I can share the recorded session. So everyone try to access the tool by the next session. Okay. So in the next session, we can discuss. I can discuss you how to work in the tool once everyone completed the installation. Okay, so our main topic is today we are going to discuss this abstraction layer, how to design in UVM, how to write the UVM program with the configuration DB files, how to access the agent, and also we are going to design this basic sequence and the transaction sequence item and the sequencer and the communication between sequencer to driver. These blocks we are executing today. Okay, so first of all, we will start with the agent. So UVM agent, what is meant by a UVM agent? So agent is a reusable verification component that encapsulate stimulus generation, driving signals, and monitoring the responses in a test bench. Normally in system Verilog, we don't have a agent. All four components like generator, driver, monitor, scoreboard, everything we will put in the environment. Environment is the top level of those four components, and we use the encapsulation as an environment there. Okay, but here we have an extra layer called agent, where we put sequencer, driver, and sequences outside the agent. In agent we have sequencer, driver, and monitor. Okay, so it provides a structured way to model and interact with the DUT. Okay, so in agent mostly we have driver. Driver means what? It send the stimulus to the DUT. Monitor means it observes and collect the DUT response. Okay, so we can do analysis and to check with the expected value, the checker, we use the checker to check the expected value and what value we got generated. Okay, and the sequencer control the sequence of transactions and send to the driver. Sequencer is a mediator between the sequence and driver. Okay, so in agent we have two types of agents. Okay, one is a active agent, one is a passive agent. What is meant by active agent? Active agent means it consists of sequencer, driver, and monitor. Three components. Okay, through the sequencer, we are connecting to the driver. Driver drive the stimulus to the DUT. That stimulus will be monitored, or monitor will get the data. Okay, response. So used in test bench where we need to drive input and verify the behavior of DUT. Whereas a passive agent only has a monitor without a sequencer or a driver. Here we don't connect any sequencer or driver. Okay, it does not generate any stimulus but observe and collect data from DUT signals. Okay, so mainly it is used for checking protocol compliance and coverage collection for assertions like that. Only passive agent is only used to monitor DUT activity for verification or protocol checking. Okay, so this is what clearly. So you may get the doubt in which case we can use either active agent or passive agent, particularly in which case, in the sense whenever you want to whenever you need to drive stimulus to the DUT, okay, there we use active agent. So when you only need to monitor DUT activity for verification or any protocol checking or any only whenever you want to get the response from the DUT, then we use the passive agent. Okay, so if you see the diagrams here, sequencer is getting the sequence item from sequences which are outside the agent, and the sequencer will send the data to the DUT. Driver is driving the stimulus to the DUT via interface. Okay, so whatever DUT got the data here, it do the functionality and send to the monitor, and monitor will send to the scoreboard or coverage report or any RAL model, whatever the blocks we are connecting. Okay, so it is an active sequencer. So we are driving the random stimulus to the DUT. But whenever you don't want to use a random stimulus to DUT, because some of the blocks in some of the project or any particular block, we don't need to generate any stimulus. Okay, we just need to drive the we just need to monitor the data. Okay, that time we can use the passive agent. Okay, so here it is a passive agent. Here sequencer and driver will not connect here. Okay, no need to connect directly. Monitor to DUT we make the connections. Okay, but how we need to write the in terms of programming? Okay, whether it is an active agent or passive agent, how to write the program? We need to select this in a configuration DB. Hello, please mute. We need to select in the configuration DB. I already told you, right, what is mean by configuration database. Configuration database means it is everything is customized. Okay, so according to our specification, according to our requirement, in configuration DB we can customize anything. If you want to make active agent or passive agent, or want to scoreboard enable, disable, or coverage report enable or disable. So like that, how many number of agents you want to connect, whether 4 number of agents or 10 number of agents, based on number of blocks, how many agents you want to connect, and which agent is active and how many agents should be off. So everything we can control using the configuration DB database. Okay, so in configuration database we write the like this: UVM active passive enum. This is just a data type name. It's a user defined name. Is active. If it is active equal to 1 means it is a active agent. Okay, so UVM active passive variable is active equal to 0. Equal to 0 means it's a passive agent. Okay, so that is how we can make the differentiation. Everyone understood till here?
Yes, ma'am.
Yes.
Remaining freshers, there are some whoever know UVM. There are some of the people, and Sampriti, Sheetal, Pranay, Ravikant, Gurshant, CB. So let me know if you have any doubts. Okay. Okay, so that is what active agent and passive agent. That is how we can control either active or passive. Okay. Next, setting agent in UVM config DB. So how we need to write in the UVM configuration DB. So UVM config DB is a file. If you want to write in a separate file, we can. But in test bench top module also, top level test bench module, we can write the set and get method. Set method will write in the test, and get method will write in the agent. Like that, we can use the config DB. As of now, no need to worry. Whenever we discuss the configuration database, then you will get understand the syntaxes, everything. Okay, but as of now, try to understand how we are writing, how we are setting up the agent. Okay, so this is what the syntax. The UVM config DB is used to configure and control test bench components dynamically. You can use it to set an agent as active or passive by modifying its variable is active. We can modify variable is active. We can put as a 0 or 1. 0 means passive, 1 means active. Okay, so syntax to set active or passive agent in UVM config DB file. So if you see here, UVM config DB is a name of the file. Okay, hash is a parameterized configuration data file. So that's why hash UVM active passive enum. This is what the variable we are declaring. It's a user defined. So before whatever we have written here, this variable and that variable is same. Set in the sense we are putting into the config DB. Okay, in mailbox, in system verilog, we use set and put and get methods, right? So here put is same as a set. Okay, set is same as put method. So we are putting the data into the config DB. In agent we can get the data. Okay, so set this dot this comma environment dot agent. So the agent name is active, UVM active. Okay, so we are making it as a UVM active. If it is a passive, if you want to make it as a passive, then we need to write this one: UVM config DB, name of that data variable set, and env dot agent is active, UVM passive. Okay, this is how we need to write in a configuration DB. Clear?
Ma'am, one doubt. So, dynamically, we are like, what does that mean?
Dynamically, in the sense here, UVM or system verilog, everything we change in a dynamically in a runtime. We can access everything in runtime. That's what dynamic in the sense. Every class based here that we are writing everything in libraries. So everything we can access in a dynamic.
Okay. Okay.
Yeah. Okay.
Ma'am, one doubt.
Yes.
Ma'am, earlier you defined another syntax. So both the syntax are mandatory or anyone to be followed?
Which one?
Earlier, like is active
This
is
one.
equals to 1 means active and is active is equal to passive.
we need to mention like this: is active, is passive. Oh, here is passive. Okay, not both are is active only. Here we need to differentiate is active, is passive. Before one is just we need to write in a top level. That's it. Is equal to 1 or 0. We can use any one, no problem. Mostly we in configuration DB we use this only.
Okay, so any agent should be definitely be defined in config DB, and this is the syntax to be followed, whether it is active or
Yes.
passive.
Yes, we need to define in the config DB. We need to we are setting the data, everything in the configuration file, and we need to get the data in our main block, agent block. I will show that.
Ma'am, if it is not defined, is there any default setting which is applies to the agent?
Yeah, default both the that mean driver, sequencer, monitor, 3 are connected by default. Every time we no need to write the config DB.
Okay.
By default, all are connected. Normal system verilog. However, we connect in system verilog, same.
So it is active by default.
Yes.
Okay.
Okay. So we'll say some example here. So mostly in top level test, we write agent.sv, test.sv, testbench.sv. I have created 3 files here. So in agent.sv, before that, see in test.sv, I'm creating these 2 configuration files. Okay, so UVM config DB, whatever I explained now, UVM active, passive enum, scope resolution operator, set method, and is active, comma UVM active. This is for passive. Okay, so whatever we have considered here, UVM active, passive enum. So here if you see 4th line, here I have defined like this. Okay, so type def enum, UVM passive, UVM active. Passive means 0, active means 1. Any before you have asked, right? So passive means we need to define or whether we need to use this value. So this value we can use directly, 1 or 0 you can put, or else we can use this, any one is enough. Okay, so here I use the same, but by using the enum data type, here automatically UVM passive will be the 0, UVM active will be the 1. Okay, so here that's why UVM active 1 I am passing and UVM passive 0. Clear everyone till here?
Prasanthi, like every time we need to set this agent in the testbench.sv only, if at all it is not,
No,
I
we
mean,
will write in a config DB. I just kept here like this.
okay.
We will just write in testbench.sv only. We will write in a config DB file. Initial begin. You can just put in the just initial begin. You can put this config DB file, any one file, and enough like this. I will show you the example here. Suppose here there is a test bench adder example. Here there is a testbench.sv. First, I already told you in the last session, right? Why do we use these macros import package? We need to import the package because all the libraries will be set in the package. So that's why we need to import here to access all the libraries of UVM. And then we need to include the interface.sv, test.sv, the top level. However, we are putting in the environment all subfiles we need to put here, and normal clock and reset generation, DUT for interface and main DUT. Here, see here. Initial begin, however, we are setting here from UVM root onwards, like that, whatever the configuration files are there, we can use like this, and whatever the previous, suppose here test.sv is there. Test.sv is also for before, not top level. The top level of agent is environment top level is tester. So in test also we can put the configuration files in the build phase. Okay.
Ma'am,
Hello.
ma'am, am I audible?
Yes.
Ma'am, in the test bench .sv, like previously, like when to use null and when to use that UVM top dot something was there.
Yes, when to use null in the sense whenever we are accessing driver. So can you tell me what is the difference between a driver and sequence item? Driver.
Ma'am, driver drives the the sequence randomized sequence to the DUT. Then the sequencer is a middle point of sequence and driver, and the sequence item is a transaction.
Okay, so null is used for object and this is used for component. Driver is a component, right? And
Yes,
sequence
ma'am.
item sequence is a object. So for objects we use a null, and for component we use as a driver. This.
Yes, ma'am. Like previously I was using null only, but there in the testbench.sv UVM top dot something was written while setting
Here,
the virtual interface.
okay, by setting the virtual, where are you talking for in this example?
Yes, ma'am. In testbench.sv.
Okay.
Yeah. UVM root dot UVM root get.
UVM root in the sense here first all the files will be defined from root. Did you join last session? UVM void, UVM root.
No, ma'am. No, ma'am. I
In,
don't join.
okay. So every library will be start from the UVM root. So UVM root is one of the top level class library. So from that only everything will be derived, the environment or agent, okay, sequence or driver, whatever, everything will be derived from UVM root. That's why here we are setting the virtual interface in the top of the UVM root. Wait, I can show. See here, UVM root. From the UVM root, all the components will be derived. So that's why first we will set with the UVM root and UVM top. UVM root class serves all the implicit top level and phase controller of all UVM components. Okay, so yeah, all the components will be under UVM root. Okay. So that is how we will write the config DB. And coming to the test.sv. So in the test.sv, we have the sequence and the agent will be connected in the environment and that to top test. So class myTest extends from UVM test, component utils, creating the component and creating the environment file and constructor, class constructor, and in the build phase. So super dot, we always need to call the super dot build phase or connect phase, whatever, because every predefined libraries will be there in the parent classes, right? So that's why we are calling super dot build phase and creating the environment here. So you already know why do we use the create method. Environment is equal to my environment. My env is the main environment file. Env is the instance. Okay, so type id. So type id in the sense any data type, whatever, int data type or string data type. So type id, create, and passing the instance name comma this. Okay, so next Here we are setting the either active agent or passive agent. Set agent to active or passive using the configuration database. So UVM config DB same here. Whatever we are putting here, we'll put in the top level test. Okay. So UVM config DB active name of that enum. Set this comma event agent env.agent is active comma UVM agent. Okay, so we can pass either 0 or 1, or directly we can write the variable name as we defined in the variable name here. We will write directly variable name. Okay, so end function, end class. So now this agent is active agent. Active agent means what? All three components will be connected. Sequencer to driver, we need to connect. In the build phase, we just create the components. In the connect phase, we need to connect the components. Okay, in the run phase, we need to run the actual functionality. Actual functionality in the sense a driver. You already know components only. In components only we write the run phase, not in the objects. Okay, sequence or sequencer, these are all objects. So we never write the sequence and sequence items or the objects. So we never write the run phase in the objects. We write only in the components. Okay, so in the driver we write the run phase. Okay, so in coming to the agent, so first we need to create the class my agent extending from UVM agent, and component utils need to create the UVM component, and UVM active is active, the name variable is active is equal to UVM active. UVM active means 1 here. So that's why we are passing as a 1, or else directly instead of this you can just put 1 also like this. Okay. Next, creating the components here, because we will create individual driver, monitor, sequencer. In the top level we will connect here three components because it's an active agent. So driver, monitor, sequencer instances are there here, and function new string name is equal to you already know how to create the constructor. So here we are passing string name, agent, and component. What is the component? Parent component null. Next, super dot new, and in the function. So why the phase build phase is function? What are the function phases and what are the task based phases in UVM?
There is only one task based phase, that is build phase, because it is time consuming phase.
Run phase.
No, sorry. Run phase. Because it
Okay.
will consume some time.
Okay. Next, why remaining phases all function?
Because it executes in 0 time.
Zero runtime.
Zero simulation time, and also it doesn't take a long time to complete the functionality. We don't have any functionality in the build phase or create phase. Okay, time taken, it's not like time taken process, but while we are driving some data to DUT or monitoring the data from DUT, it totally time taken process. First clock cycle, so what data need to be drive, and next clock cycle what data. If reset is high, what is the data? If reset is 0, what is the? So everything we need to drive the signals. Okay, so it takes a lot of time, so it's a long running process. So actual test will run in the run phase only. Okay, so after compilation is done, in the SOC level, to go to when the test from main phase to test run phase, it takes lot of time. Okay, in the main after compilation is free to enter into the main test, it takes some time. Up to there it will make these creation, connections, all these things. In the main test it will start running the actual functionality execution. Okay, so in that we need to check if any error is getting or any debug is getting, first of all, we need to check whether the test is entered into the main or not, test main. If test is entered into the main, then the error is from functionality, actual functionality, driving the signals or monitoring the data. Okay, if test is not entered into the main, still it is in process of creating only, maybe we got the error in that process. Okay, so here build phase. So here we are passing whether it is get. So if you see here in test.sv, we are setting the data in config.db by using a set method. Okay, this we use this. Before one person asked, right, why do we use this? This is used for components. Null is used for object. Let me know why. Okay, so get here in 17th line, get this comma active is active comma is active. Okay, so getting the data here and warning. If it is failed to get the data, then we get the warning statement or any error statement you can write. Agent is not is active is not set by default to UVM active. Okay, so it just give the warning. And then monitor is equal to just creating here my monitor type ID, creating the MON instance. Okay, next, if E is active is equal to UVM active, then we need to create these two, driver and sequencer. Okay, if it is a passive, then no need to write this entire thing from 24 to 28 line. No need to write, just 22nd line is enough. Only monitor is enough. Okay, because it's active. Okay, so if it is not active, then we need to write these two. Okay, so is active is equal to UVM active begin drive is equal to my driver, name of the driver component, class name, type ID, create drv, comma this. You already know why do we use this keyword. And sequencer, my sequencer, type ID, create sequencer. Okay, so why do we use the create instead of new in UVM?
Because we need factory to create the object.
Okay, override the object. Okay, so here also in this example also we have in agent we included sequence item, sequencer, sequence monitor, everything. It is an active agent, so created the component utils agent, and in function build phase created the driver, sequencer, monitor. Okay, after creating this, we just connected. In the connect phase, we make the connections between driver to sequence item port. How do we make the connection? Using TLM port. Okay, so once
Ma'am, in this new parent is not equal to null, and in last one it is parent is equal to null. I'm not getting the new function.
Here,
parent is equal to null as done in the last example. Here it is not done the parent equal to null. So why exactly this
no,
parent
here
equal to null?
also, okay, here because we didn't return any parent class, right? We just created normal only for agent. Here we already have the parent class, which is defining to UVM agent, UVM component parent. So here I just written only UVM agent and not pointing to the remaining components. That's why. Here agent is connecting with the driver, sequencer, monitor, all these things, right? So that's why here we didn't took any null. And here it is not pointing to any driver or sequencer. Just I have taken the instances but not connected. That's why it is pointing to the null. Okay.
Okay.
So Same here we just added extra connect phase because we need to connect by using the TLM port. That thing we will discuss later. Okay, so this is how we design the agent. Everyone clear? Active agent, passive agent concept.
Yes, ma'am.
In the last session, I already told you, right? I shared the shift register design in Verilog HDL. I told you to start with the system Verilog program, and then we'll work on with UVM. How many of you did that? Have you started, anyone?
Yes, ma'am. I think you have shared serial and parallel out, I think.
Yes.
Yes,
I
ma'am.
shared system Verilog reference code also.
Yes, ma'am. And you have shared adder UVM code, I think, for reference. For UVM, yes.
For UVM, I shared, and also system Verilog also I shared.
Yes, ma'am.
Okay, so parallelly start with the system Verilog and also UVM basic building blocks. You can start. Okay,
Yes, ma'am.
so parallelly you will get understand what are the main differences and how to work on these components. Okay, so I think no one have the doubts. So shall I move to next topic? Okay, next coming to the sequencer driver. So what is the difference between sequencer driver? So how we are going to connect in terms of programming? We need to follow some set of methods, right, in a sequence and driver. So what are those methods and how exactly driver is going to drive the data to DUT? So coming to the UVM sequence item, it's a transaction. So in system Verilog, however, we write the transaction class. In transaction class, we put every variable attributes we call or the variables which are going to be randomized. Okay, so that transaction data we are putting into the we are generating the randomized data and putting into the mailbox. From the mailbox in driver, we get the data and send to the DUT. That is what actually happened. But here we call it as a sequence items. Okay, so in sequence items, suppose address, data, write, read signals out there. All these things we consider as a field macros. Okay, so a data object that represents a single transaction, example memory or read or write, and contain randomizable fields. That is what sequence items. And UVM sequence. UVM sequence, a class that generates a series of sequence items and send them to the sequencer for execution. Okay, same as a generator. Okay, next UVM sequencer. Sequencer is a mediator between the sequence and the driver. Okay, a component that acts as a bridge between the sequence and the driver, managing the transaction flow. And UVM driver. UVM driver, you already know, a component that receives the transaction from the sequencer and converts them into the actual signals to drive to the D. This is what actually happened. Okay, so UVM sequence. In UVM sequence, there will be set of sequence items. So the sequence item is nothing but one is address, one is data, one is read write signal, or one is a strobe signal, or one is p slave error, or p address, whatever. Okay, and clock reset also. And these sequence item we are sending to the UVM driver via sequencer. Sequencer is a bridge between these two. These two will be there in the agent, and this will be in the tester. Okay, so sequencer, we don't write any program, any functionality for this. By default, the sequencer have its own logic. It have its own mediator logic in the sequencer. Okay, so that thing we will drive to the UVM driver sequence item. So these randomized sequence item we are sending to the driver via TLM port. In system Verilog, we just use the mailbox, which we use the put method and get method here. But here we use the TLM port. One is a port, one is a export. Okay, so maybe next session you will be getting clarity on these ports, how to write the get port and put port. Okay, so this is what the flow of execution. And next, how in
One small
hello, yeah, please tell.
hello, one doubt, Prasanthi. In between the sequence and sequencer, how we are driving that? I mean, like for example, here we are using the TLM port or mailbox in the system Verilog, but how we are driving that? I also forgot
Yeah.
that. Between the sequence and sequencer.
Here we use a body method. Body is a default method. We need to use body. Within the body, we write main functionality, connecting this sequence to the sequencer, pre-body, post-body, or callback methods. So you know the callback methods, right? So in system Verilog, we have pre-randomized, post-randomized. Same here, we use body method.
Like for to and fro both sides. Like here it is, I mean, like it is.
Here, bidirectional, why in the sense we will send the data to DUT and DUT will send the response. We are sending the number of sequences and DUT will send the response also. What sequences are received and what is the, if there is any error or no. The response will be getting here. That's why bidirectional.
Okay.
Yeah. Okay. Any other doubts, others? So if you see here, first we will create sequence.sv file, sequencer.sv file, driver.sv file, and also sequence item.sv file. 4 number of files must be there. Okay. In sequence item.sv file, same as a transaction class. In transaction class, however, we declare the input variables with a rand data type, output variables, we write the constraints and some display statements, right? In sequence items also same. We create the object by using the object util macro. In that we'll write all the variables by using tqvm macro, field macro. Okay. So coming to the sequence, from the sequencer to the sequencer, first we create the item, sequence item. Okay. And wait for grant. Here we are requesting to sequencer, request to sequencer. Here we create the request, that means sequence. We need to request to the sequencer, and based on the arbitration, which one need to be selected based on priority. So it will grant the sequence. Okay. So after grant the sequence, so here in sequence we are ready to do the randomization. So randomize method. After doing the randomize method, again send request. So sending the sequence item. So whatever the data is randomized here, sending the data to the sequence item by using the method. So here it is getting the randomized data and sending to the driver. Get item from FIFO. So get next item. So here driver use the get next item method. Okay. After get next item, it is sending to the signal from driver to DUT, and also this is the process here. It again wait for next grant, randomize and send the data. Here it will give the get next item like that. How many, suppose here 10 number of transactions are there, parallelly do it send the data 10 number of transactions to driver. Okay. And finally item done. If item done both sides, it will send the response. So that's why it's a bidirectional. Okay. So item done response, it will be sending to here, and also item done. Wait for item done. So it is waiting for item done. So it will send, okay, 10 number of transactions are completed my side. So whether it is received 10 number of transactions are there. If it is received this 10 number of transactions, sending item done. So it is waiting for item done. Once item done response is received, it closes the sending the transaction. So get response. So here it is getting the response of the from the driver and sequencer. Okay, understood till here?
Yes, ma'am.
Any doubts?
One doubt. Suppose one sequence item has been sent and the DU2 sends its response back and sequencer sends the item done. Then only next item will be sent, or all the 10 items will be sent?
No. Here another concept is there. Item done. In UVM we have objection. Do you know phase rise objection, drop objection in UVM? Actually, we follow that method. Okay, rise objection, drop objection means here we are rising number of transactions equal to 10. So whenever these 10 transactions are passed to here, here we'll write some drop objection. Okay, so whenever it is activated, then both are will be in sync. Okay, so whenever both are in sync, then we'll get the item done concept.
Based on that rise objection method, then like all 10 sequence items will be sent to DUT first, then item done, that response will be sent back to sequence, correct?
Yes. So if you see here, phase dot rise objection, phase dot drop objection. So a component that rises objection remains in same phase till all the objections are dropped. So rising and dropping of objection is done in run phases. Okay. So example, so run is completed till here. So here 100, suppose phase dot rise objection in agent, and here in driver phase dot rise objection. At 100 time units, it is doing some work. Okay. But here at 10 time units, it completed its work. Okay. But still at 100 time units also it is doing some work. Then these driver also need to wait until this one is completed. Okay. So whenever both are completed, mutually they need to wait both sides. Okay, so when both are completed equally both sides, then drop objection. So here it is drop objection is active, and here also it is drop objection is active. Based on that, the driver, sequencer, agent, all blocks will be communicated, including number of transactions also.
Ma'am, how will we know like which component takes how much time? Like how you have written agent takes 100 time units and driver
Yeah, I
takes
just
10
told it now just for idea. Okay, we will discuss in the coming sessions in depth. We need to write the program for that. How this is a simple example, but we can write for number of transactions also. We can pass the number of transaction value in a phase and drop objection also.
Okay.
I have one question. So usually in a sequence, we have the data items and we drive that stimulus to the DUT. Now, if we get say the item done and we get the response and one sequence is complete. Now, suppose uh, we have a sequence where we are driving stimulus. You get some response from DUT and then remaining stimulus you want to drive. In this kind of scenario, what can be done? I mean, is it possible in this, or should we wait for the response and then drive the remaining stimulus? That's my
So first of all, it totally depends on the phases. Okay, so all these things will be done in the run phase also, but the end of elaboration and like last stop phases, all this there, right? Based on that, it will be checking whether to drive the next simulation or will it stop for the transaction. Suppose even in the same run phase, first you want to complete entire transaction first for one sequence, then you need to make the grant. In the sense that won't be possible. First of all, we will drive all the signals to the driver. Parallelly it will drive to the DUT. Then once both sides, we will check the transaction is done or not, complete transaction is done or not, then we'll get the response signal. Did you understood? In system Verilog,
yes.
suppose we just write at the declaration time, we write number of transactions as a 10, repeat of 10 or number of transactions as a 10. Once these 10 number of transactions are completed, then we'll get final some display statement like transactions completed, like that. In the agent also, we will pass the value, transaction value. Okay, same way you can do, or else individually if you want to try, we can, if it is possible, we need to check.
Yeah, I think we can discuss offline, but the thing is like sometime what happened, you want to try like initial transaction. So you have 10 transaction, you just want to try initial sanity transaction, like first on 2 transaction, and then duty said is ready to take more transaction. It gives that kind of signal, and then remaining 8. If it's not ready, you will not send the remaining 8 transaction. In this kind of scenario, how this whole system
For
work.
that purpose only we are holding in the data transactions into the port, right? In FIFO, we need to hold the transactions in FIFO because driver is not able to drive all the sequences at a time. So for some time we are holding the data.
No, that is true. But in this transaction, I think we can take it offline. Don't want to disturb everyone's time. But point is, this FIFO, we are sending all the 10 transaction. We are sending one by one, but we are not actually waiting for something from DUT. We are not saying that, okay, this DUT signal goes high or low. For example, it's valid or okay to drive next transaction. If this kind of response come from DUT, because I see that kind of scenario. So, but yeah, we can discuss
Okay,
this
yeah,
later.
no problem. I didn't got clarity from your question.
Sure, we can talk about this later.
Okay, fine. Okay, what about others, sir? Did everyone understood
Ma'am,
here?
yeah, ma'am, what if we have like a 16-bit data, like for an example, if we are taking some FSM sequence detector and we are passing a 16-bit data, how it will pass? Like it will take single bit and check.
No, here 16, it doesn't consider with the number of bits, number of transactions. The transaction can be a 16-bit or 32-bit, whatever, 64-bit, 128-bit, whatever. It depends on transaction. Suppose you are telling address is a 16-bit size. Okay, 16-bit size means suppose I'm storing the data as 86. Okay, so you are telling this in this 86, suppose I'm taking as a 8-bit size some value like this. You are telling whether it will transmit one by one. Here it is not a serial communication or we are not considering like this entire 86 is a one transaction. This entire 86 will be transmitted at a time, not as a 16-bit or 32-bit. Did you got my point?
Yeah, got it.
Okay, so we'll try to write some program for this. What about CB, Pranay?
Yes, ma'am. Understood.
Okay. So coming to the sequence item, first we need to create the sequence item. Any example, whatever the example you consider. Class my sequence item, name of the user defined, extends UVM sequence item. UVM sequence item is the predefined library. Okay, parent class. So UVM sequence item is a object. It's a it's not a component, it's an object. So that's why we need to create using a object. So UVM object utils my sequence item factory registration. And then whatever the variables are there, here we kept the variables like this, or else we can create the macro directly here in the object begin. Take UVM field int or whatever. So you need to pass whatever the variable is there, address variable. We can put some verbosity levels, okay, or which one you want to on or off. Yesterday I told you, right? So in do hook methods, copy, compare, clone. So if you want to on all the methods, if you want to access, so you can keep as a UVM all on. If you don't want to access any copy or compare, like no compare, UVM no compare, UVM no copy, like that. Or sometimes we pass the verbosity levels like medium, high, low. Those things coming sessions we can discuss. So it is just a priority. So which one need to be executed, like that we need to write the program. Okay, so if you see here sequence items. So UVM object util sequence item, UVM field int, passing the variable a comma UVM all on b c sum, like that. Finally, UVM object utils end. So that is what the difference between system Verilog and UVM. Okay. And then function. Yeah.
Santi, small doubt. Like if we define by UVM field and these variables address data, so still we need to write this rand bit 7 down to 0.
In UVM, we no need to use the rand, but if you in UVM, we no need to write this rand. By default, whenever you are writing these field macros, automatically this will be accessed for randomization.
Okay, but how we get to know the size of this like variables like address data if we just write in the UVM field?
Interface, we already declaring the sizes of these variables, right?
Mm-hmm.
In interface, we can declare. Or else here we can declare separately. Okay.
Okay, thank you.
And next, but these all compulsory. Macros are not compulsory. If we tell macros just for factory concept. If you want to access the methods, copy, compare, do hook methods, then we need to write the macros, or else not required. And next, function new sequence item, creating the constructor and the constraint. Okay. And coming to the sequence, in the sequence main method we need to write in the task body method. So first create the class my sequence extends UVM sequence, and as it is a parameterized class, we need to pass the transaction and the response. If response is there, if you are getting the response from driver to sequence item sequence, then you need to write the response also, comma RSP, like whatever the response. Or else we can simply put the sequence item transaction. Okay. And object utils my sequence constructor, and in the main virtual task body, creating the transaction and repeat 5 begin end. Here we need to create the transaction class. Okay, so generating the 5 transactions here, creating the transaction class and sequence item of transaction. So sequence start item of transaction. So if you see here, create item, wait for grant, and here we need to use the start method, start of transaction. If transaction randomize is not high, then we'll get the error if it is failed. So randomization is failed, and then finish item of transaction. So whatever the methods we are writing here, instead of these methods, we can simply write as a macro called UVM do of whatever we are passing here, transaction. We can use this transaction here. Okay. So that no need to write all these steps, 4 steps. Automatically it create, do the randomization and send to the DUT. Okay. Suppose if you are writing any constraint, inline constraint here, while doing the randomization, sometimes we write using with the what are the variables, address data. So with address is less than 100 or data is greater than 100 something, if you want to write as an inline constraint, we can use the macro called UVM do with. So directly we can write the constraint here. Okay. Did you all understood till here?
Here
Ma'am,
start item.
Mm.
Okay, here start item and finish item are inbuilt functions, or
Inbuilt
we need to
functions.
declare? Okay,
No.
okay.
Body also. Mostly
Okay,
we
okay.
write body only for UVM. If you want to write extra functionality, we can write pre-body, post-body. Pre-body is to just to write the initial statements. Post-body is like whatever the expected final value statements. If you want to print those methods, we can use callback methods. Okay.
Okay.
So after that sequencer, we don't have much program. Whatever the
Hello?
project is, we don't have.
Hello?
Yeah.
Yeah, Prashanti, can you go back to the sequence, please? So in the line number 11, right? So we are creating the transaction object every time. Is it necessary? Or we can put
Transaction
it
object every time, where we created every time.
line number 11, right? Like
Hmm.
we are creating it for 5 times, right?
We are not creating it for 5 times. We are telling it as to repeat 5 number of times. Okay, inside that you are telling. Okay.
Yeah.
Yeah, it's required to create those many times, because every time we need to, we cannot access the object, the same object, right? We need to create the transaction. Okay.
ma'am, small doubt, one more thing.
You will
So
be
here,
getting the if we, even if we write here, sometimes most of the cases we will get the error within this block, because here it doesn't accept to create outside the beginning. While we are doing the simulation, we can check that thing. Okay.
Yeah, yeah. We'll check this.
Yeah. Okay. Yeah, next. Any doubt?
yeah, ma'am. Here transaction means it's include all the data types, right? Address, data, whatever we declare. Combination of everything combined is called one transaction.
Yes.
Okay.
Whatever
Ma'am,
here 3 variables are there, even if you put 100 variables, it comes under one transaction. At a time, all will do the randomized and send to the DUT driver.
yeah, okay, ma'am.
But
And
every
this,
variable we need to access separately. While you are passing from driver to DUT, we need to access transaction.address, transaction.data, transaction.write enable, like that. Yeah, tell.
Acha, okay, ma'am. And ma'am, one more thing, this body and all these inbuilt functions, start item, finish item, are they
Yes.
part of the starting? Can you please go to top? Initially, we declared few packages, right? UVM underscore package. Are they part of that, or else the part of other include
No, no.
macros.svh?
Start, These all are macros only, where it is. Here start and finish, these all comes under packages, and wherever we return these macros will comes under UVM macro. Libraries, everything will comes under package.
Okay, ma'am. Yeah.
Okay. So these all are default.
I have one doubt. Like in sequence item, we can also define the outputs, which doesn't require any randomization.
Outputs you want to write by writing any display statements, huh?
Like my doubt is if I am randomizing this in sequencer, in the sequence, so the variables which are declared rand will be randomized. Suppose I have other variables, I'm just declaring them as bit. Those
will be not randomized. Hello. Okay. Next. Hello.
Yeah.
Yeah, tell.
Like if I've defined the outputs in sequence item, those will not be randomized. You said like transactions will have the address and the other variable that is defined. Transaction.address, transaction.data, transaction.write enable. All of these are
randomized inputs only.
So this will be randomized. If I give some other variables which are not rand in the sequence item, that will not be randomized, right? That will be as suppose output signals I am just defining
It's output or input, whatever, wherever you don't mention the rand, those variables will not randomize.
So output will be getting from DUT, right? You need not randomize it.
Sometimes if you miss to put rand for input also, those inputs will not randomize. That's what I'm telling. Sometimes if you forgot for address and data, you may forgot to put rand, but it will not consider as a input. Even it is considered as a input, it never do randomize. Okay. Obviously for outputs, we don't mention any random because we don't randomize the output we'll get from the DUT. Next, sequencer. So sequencer will write a normal, just a mediator logic. Even we don't write any mediator logic. We just create the class and we just create the component factory registration. Okay. By default, it contains its own logic. Okay. So we never write any functionality for this, whatever the project it is. Class MySequencer extends UVM sequencer. So we need to pass the parameter here, response and the sequence item, and component util MySequencer and constructor and class. Okay. That is what sequencer. And coming to the driver. So in driver, first we need to create the class MyDriver extending from the UVM driver, and we need to pass the argument. And it's a component, so we need to write with UVM component utils MyDriver, and creating the virtual interface because we need to take the virtual interface with physical interface. Next, constructor and run phase. Actually, in the here in driver, we write the build phase also. We don't write the connect phase, but we write the build phase to get the config data. Okay. So virtual task run phase, creating the transaction here, and forever begin sequence item port dot get next item off. That's what TLM port. Whether you use port, put port, or get port. Okay, so here we are using sequence item dot port dot get next item of transaction. So whatever we are passing from sequence, start item of transaction, after sending this randomized, so it will be getting the data here, get next item, then printing the data, UVM info statement, whatever the variables, and driving the data to the DUT, transaction data to via virtual interface. Here we didn't written any blocking block or mod port. Okay, so directly we kept VIF dot address. If you write blocking block or mod port, we need to set the path. Okay, next sequence item port dot item done. So item, all the variables are sent to the DUT, all transactions, and item done. So whenever item is done, getting from here, it will pass to the sequence item finish item. I mean sequence class finish item. Okay, clear till here, everyone?
Out actually the in the diagram you had mentioned there is a TLM FIFO. So is that a hidden FIFO that we don't mention in sequencer?
TLM FIFO
FIFO
is
between sequencer and driver?
See, TLM port is FIFO is some cases only we use. Suppose the producer and consumer. Producer and consumer means one side is a sequencer and one side is a driver. So which one is using your initiator and target? We'll have two initiators and we'll have one initiator and one target. So whether you are putting from initiator to target or target to initiator like this. See here, producer is the initiator and here is the target. And here is if it is a port and export, we have like this. Okay.
Yes. So okay, for our example, sequencer is the producer and the driver is like a target. So we have a connection, right? But we are not explicitly mentioning the connection between the sequencer and the driver. So
Here,
it is by default there as a part of agent code.
See here, I didn't written any build phase, connect phase. In even in driver, we don't connect. Why? Because for driver top level is agent. In agent, we connect. Already shown here how to make the connection. Sorry. Okay, here in agent I did it. Okay. Wait, I will show you another example. See here. Connect phase. Driver dot sequence item port dot connect. Sequence item port. Sequence item export. One side is a port, one side is a export. Based on that, we make the connection.
Okay, that connection happens in the agent. Okay, fine.
Connect phase agent. Okay, because agent is the top level, right? For driver sequencer, that's why we connect there. If it is active agent, we connect with the monitor. Sometimes if you see here, monitor to here 1-to-1 connection, sequencer to driver connection, but here monitor to two connections are there. Scoreboard is one side, coverage is one side. So 1-to-2. 1-to-many means analysis port. We use analysis port. So for here monitor, we use analysis port. So go to the monitor. So if you see here, 8th line, UVM analysis port sequence item collected. This analysis port will be connected to the scoreboard here, UVM analysis implementation port. So UVM analysis implementation port, and here UVM analysis port to implementation, one side port to one side implementation. We will discuss in the coming session clearly. And coverage also. Here also we'll be having the analysis port. Top level we will connect. See here, monitor, coverage analysis, environment. Environment is the top level for monitor scoreboard. So here we will connect monitor to scoreboard, monitor to coverage. Okay.
Yeah.
Before one person asked, right? So how we make the transactions? I told we use rise objection and drop objection. This is how we use to make the synchronization between number of transactions. We use drop objection and rise objection. Okay. So this is what overview of agent, sequence, item, sequence, sequencer, driver. How to write the program. Hello.
I had a question. So in the driver, when you're sending the transaction, we usually send it as non-blocking, right? The when we are driving the transactions, the transaction address data. So
mostly we use a non-blocking assignment. Here it's just a simple example.
okay, just wanted to
used blocking assignment.
Okay, and also all the tasks, is it do we have to declare it as virtual tasks?
Yes, everything is virtual here.
So all the tasks we have to have it as virtual?
All the tasks
every
we
time?
need to use as a virtual only in UVM.
Okay,
because everything by default, if you want to override the data, it will be easy.
Okay, and I had a question regarding the TLM and analysis ports. I don't know if you'll cover it later, but regarding like let's say the port is connected on one side and there is no export connected. So will it like error out in that case?
Port is one side and no exporter, or port to port also we can connect.
What if one of the side is missed connecting?
Then middle we need to use some FIFO block for temporary storage.
Okay.
Yeah.
No, I think the question is like we have only port, no export. We just declared it. Will it throw error?
Obviously, how we can connect? Suppose monitor to DUT, or suppose if agent, if we consider we are just
No.
getting.
Question is like we didn't do any connection.
No.
Is it compilation? It will throw compile error or
yes.
runtime
Yes.
error?
Syntax error. Not runtime error, syntax error only, compilation error.
How about for analysis port?
Analysis port also, anywhere 2 ports are mandatory, right?
For analysis port, it's not compulsory.
1-to-1 we can connect, but not compulsory of putting multiple. If you use one analysis, we can use 1-to-1. That's not a problem.
If we leave it alone also, it will not throw error. Analysis port.
No problem. Monitor you created as an analysis, and scoreboard you created as an analysis. No need to put extra another block. You can leave it alone. That's not a problem. You don't.
No, what I meant is, let's say monitor in the monitor side, I created like an analysis port, okay, and on the other side, no, there is like no connection, like I'm not connecting the scoreboard.
Here you are. Okay.
So what will happen in that case? Like will it throw an error? Because I'm connecting only on the monitor side, and let's say there is no scoreboard or nothing that I've connected on the other side.
I think
no
there will
coverage,
be
nothing.
You're just creating the monitor and you're not making any connections. Then you just create the monitor, you can leave itself. No need to connect anything. Just you can create itself and leave.
Okay, so it won't throw any kind of error.
No need to. It doesn't connect with anything. Error will not give. Any compilation error we don't get. Syntax error, nothing. Compilation error we don't get. But in functionality wise, it will make some like functionality wise. If you want to check the output, we don't get.
Okay. But it's not the same with TLM port, right? Like because when I'm
TLM port, we need to connect 1-to-1 compulsory.
Okay.
Okay. So Pranay, Chakravarti, remaining for their Sampriti.
Yes, ma'am.
Any doubts, Vinita?
No, ma'am.
Okay. For everyone, I can share you the recorded session for your mail ID. Okay. It takes some time. Meanwhile, I will share you the codes. Okay. So we'll discuss in the next session regarding TLM port and phases concept. So whatever the doubts you have, you can ask in the next session and practice till then. Okay. Any other doubts? No? Okay, then thank you all.
Thank you.
Thank you, ma'am.